Welcome to Algebra 1. The learning goal for this episode is to understand the concept of slope. First, we need to understand some vocabulary. Mathematicians define slope as the ratio of the vertical change to the horizontal change between any 2 points on a line. Instead of saying vertical change, we often say rise. And instead of saying horizontal change, we often say run. That's just a little easier to say. Let's look at this line as an example. If we look at these 2 points on the line, they have coordinates x1, y1 and x2, y2. We use the variables instead of actual numbers because we're talking about the general case of a line, not a specific line with specific points. Well, the rise for this line, how much vertical change there is going to be the difference between y2 and y1, the two y coordinates of the points on this line. Our run, or horizontal change, is going to be the difference between x2 and x1, the two x coordinates of points on this line. It's really important to understand that we can pick any 2 points on a line to calculate the slope, as the slope of a line is always the same or constant. Mathematically, we often use the variable m for slope. It's the ratio of vertical change to horizontal change, or rise over run. Recall that ratio is a comparison of two numbers by division, so we can write this as a fraction. Again, the rise is our change in y, and our run is our change in x. So our general formula for slope is going to be y2 minus y1 divided by x2 minus x1. For any 2 given points on a line, we can fill in the x and y coordinates, subtract, and figure out the slope. Let's look at some examples. We want to find the slope of this line that has already been graphed for us. To find the slope, we can pick any 2 points on the line. To make our life easier, we try to pick points that are easy to work with, so they typically have coordinates that are integers, but please keep in mind that doesn't have to be the case. So for this graph, 2 points that would be easy to work with are -3, 1 and 3, 3. So now we use our definition of slope, rise over run, or the change in y over the change in x. Or we can think of the formula y2 minus y1 divided by x2 minus x1. So for our rise, we substitute in the two values we have for y. So for y2, we take the 3, which is the y coordinate of the second point, and subtract 1, which is the y coordinate of our first point. That gives us a rise of 2, which hopefully is pretty clear when you take a look at the graph. Even though we have a formula, it's helpful to look at the graph both to visualize what's going on and to get a better understanding of what we're actually talking about. For our run, we do the same thing with our x coordinates. We take the 3, which is the x coordinate of our second point, and subtract the -3, which is the x coordinate of our first point, and get a run of 6. It's very important to realize that it doesn't matter which point you think of as the first point and which you think of as the second point, as long as you do the rise and the run in the same order each time. So with a rise of 2 and a run of 6, we get a ratio of 1/3, which is our slope. Let's go through the process again for this line. We pick 2 points that are easy to work with. In this case, I picked -3, 5 and 3, 1. But again, keep in mind you can pick any 2 points. First, we recall our definition for slope, and then we use our formula and substitute 1 in for y2 and 5 in for y1. Then substitute 3 in for x2 and -3 in for x1. When we set that up as rise over run and simplify, we get a slope of -2/3. Now for this example, they don't give us the graph, but instead give us 2 points that are on a line and ask us to find the slope. Now we could choose to graph this to get a picture, and that's fine if you want to do that, but we can actually figure this out directly from our definition. Note that the y coordinates of our points are 8 and 5, and the x coordinates are 3 and 2. When we substitute those values into our formula, we get a slope of 3. Notice how if we change the order we use the points, so doing 5 minus 8 and then 2 minus 3, we will still get the same slope. It does not matter which order you calculate rise over run, as long as you use the same order for both rise and run. Let's try another one. Again, we use our definition, and we identify the coordinates of our point. From there, it's pretty straightforward to calculate our slope of -3/2 simply by filling in the correct coordinates into our formula. Again, if you choose to calculate it in the reverse order, it still comes out to be the same slope. Here's another example, this one with a twist. Again, we use our definition and our given points. But this time, our rise turns out to be 0. Since 0 divided by anything is still 0, that means our slope is going to be 0. As you picture what a slope of 0 looks like, you should be able to see that this would be a horizontal line through y equals 5. All horizontal lines have a slope of 0 because they don't rise. One last example, this one with a different twist. Again, here's our definition and our points. But this time our run is 0, which means we have 0 in the denominator. In mathematics, it makes no sense to divide by 0 because we simply can't divide something into 0 groups. So when we try to divide by 0, we say it's undefined, which means the slope of this line is also undefined. If you picture that, no run at all means this is a vertical line, in this case through x equals 2. All vertical lines have a run of 0, so we'll have a slope that is considered undefined. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you with the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself, then I'll show you. So, for this problem, our first question is, what are we trying to do here? What we're trying to do is figure out the slope from the graph of this line. Your next question is, how do we do that? First, we need to think about what slope means. It's our rise over run, or our change in y over our change in x. Now what? Now we pick any 2 points on the line. We try to pick points that are easy to work with, so I picked -1, 1 and 1, -5. But you could pick any points you wish. After we pick the 2 points, what do we do next? Now we calculate our slope by filling in the y coordinates to calculate our rise and our x coordinates to calculate our run. In this case, that means we fill in -5 minus 1 to calculate our rise and 1 minus -1 to calculate our run. It's important to remember that you could choose to do it in the opposite order. 1 minus -5 for our rise and -1 minus 1 for our run, and it would still work. What do we do next? Now we simplify, which gives us a slope of -3. Are we finished? Yes, the problem asked us to find the slope and we did, so we're finished. Let's try another example. What are we trying to do here? We're trying to find the slope of the line that goes through these 2 points. What do we do first? We recall our definition and formula for calculating a slope. What's the next step? Now we fill in our y coordinates to find the rise and our x coordinates to find the run. Then what? Then we simplify. Our slope in this case is 4/3. Let's try one more example. What are we trying to do here? Again, we're trying to find the slope when given 2 points. What do we do first? We recall our definition and formula for slope. And the next step? We fill in the y coordinates to calculate the rise and our x coordinates to calculate the run. Now what? We simplify. In this case, our slope is 0. We're done, but let's take a moment to think about what a slope of 0 really means. What does that mean for this line? A slope of 0 means it's going to be a horizontal line, in this case through y equals 4. Note that the problem didn't ask us to tell them that. The problem just asked for the slope, so we were done when we found 0. But it's always good to think about what your answers mean. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problems on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. Let's do one more. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to understand the concept of slope. We did that by defining slope and coming up with a formula to calculate it given any 2 points on the line. Those 2 points can be points we find ourselves on the line when given a graph, or they can be points that are given to us.